Hello and welcome to Data Science. This is the first video on a lecture series on machine learning. And Data Science channel is all about learning concepts of data science through examples and case studies. And there are absolutely no prerequisites to start this. Just enough maths, high school maths, and a bit of common sense. That's it. Then we are good to go. So the first chapter is what is machine learning. Now, as you have heard, machine learning, AI are the buzzwords and they are now prevalent in almost all the industries. You might have heard of Andrew Ng who says AI is the new electricity, right? And tech companies are constantly looking for talents in this domain. Enormous research suggests that the demand is not going to come down anytime soon, and machine learning has now just become part of our daily life, even if we realize it or not. And have you ever wondered that while you are viewing videos on YouTube, then the YouTube's recommendation system keeps you suggesting the videos which you are interested in, same kind or genre of videos. And not only YouTube, various social media companies, they keep you engaged through their content, which is a result of recommendation systems which are actually based on your interest. Also, have you ever thought how our email account automatically identifies spam emails, and the someone's bank, they are reminding someone that there might be a possible fraudulent transaction on his or her credit card. So these are some of the applications of machine learning. Let me list down some of the applications so that you are better aware of what are the current roles of AI and machine learning in our economy. So fraud detection, spam email detection, personalized digital advertisement is a big one, and search engine result refining. So you might have seen that when you type a word on Google search engine, then it automatically recommends you what is the next word of the sentence, maybe which you are looking for based on your activity or the activity around your area. And product recommendation systems employed by Amazon and Flipkart, e-commerce websites, and Google self-driving car. You must have heard about that. And there are enormous plenty of these industry specific applications of machine learning. But the question still remains what it actually is. So now we are going to dive deep into it. Introduction to machine learning. Now, I want you to first understand how we learn before understanding how machine learns. So let's just start with an example. As I said, this series would be more of a case study or exampled approach to understanding the concepts. So take this example. A company released an advertisement to market its product. They want to identify people who will be interested in buying their product. So case is pretty clear. A company releases its ad and they want to know who are the people who will be interested in buying their product. Now they made a graph. On the x-axis is the time spent by an individual watching that ad, and on the y-axis is a variable which indicates whether the person is interested in buying or not. 1 is yes and 0 is no. This is you. So, and this is me. You are not interested in buying the product and I'm interested. Plus, you have spent a relatively smaller amount of time on the ad and I have spent a larger amount of time compared to you. We have two data points. We also call them as training examples. Now this is the time spent by another guy. The time spent by this guy is somewhat in between the time spent by you and me. What we want to know is if this person is interested in buying the product or not. Can you predict it? Well, maybe just two examples aren't enough. He can either be interested or not interested. So what we are really looking for is more examples. So now the company provides more examples to you, and again the problem is same. What do you think about this guy? Is this guy interested or not? Now we have more examples, and as you might probably have inferred by now, this guy looks more like he's not interested because most of the training examples in this area of time spent are not interested, right? He's not interested. Here time spent on ad is the feature, and is interested is the target variable or label. And as you witnessed, our performance in predicting the label or target for a new example increased as we got more and more examples. This is the basis of machine learning. And this example you saw is a common binary classification problems which has maybe you can't think of, but it has enormous application in the interest industries. Now let us have an insight how a machine would interpret this problem. So the machine starts with a decision boundary. So it starts with any decision boundary between the two times, and you can say let us say we started with the time t1, and the machine classifies anyone who has spent the time watching the ad greater than t1 as he is interested, and whoever has watched it less than t1 then he is not interested. Now with the incoming of new examples, are all decision boundaries no longer valid, right? And for every incorrect prediction, our algorithm which we defined on our previous slide gets a penalty, and we'll talk about that penalty of wrong identification later. But for now you can think of it as, say, if you identified three wrong examples, then there would be -3 in your score. Okay, now we need to shift this decision boundary so that we can minimize those penalties. We need to change them so that, to accommodate new examples, or in machines terminology, reduce the penalty associated with misidentification. So here is our new decision boundary. Anytime greater than t2, if a person has spent watching that ad, then he is interested, will classify him as interested in buying a product, else will classify him as not interested. In a similar way, our machine learning or optimizing an algorithm in general will try to minimize the penalty of misidentification for all examples. And you might realize it that even a human being tries to do the same. We try to shift our decision boundary so that we can minimize the misidentification. So a machine works in the same manner to reach a final decision boundary. Now let's have some a formal definition so that you have got something to take the home with you, right? So definition goes as follows: a computer program is said to learn from experience E with respect to some class of task T and performance measure P if its performance at task as measured by P improves with experience. So as we saw in our example, E is the number of training examples, and the task of correctly identifying the target variable increased, our performance increased as we got more and more training examples. And what is the performance? The penalty which our algorithm tried to minimize by altering the decision boundary. So basically our penalty decreased as our training example increase. Machine learning is the study of computer algorithms that improve automatically through experience. That's a smoother definition. That's it for now, and please subscribe if I'll be posting regularly in this lecture series. And if you like it, please subscribe and like the video, and if you have any doubts, please raise it in the comment section. Thanks for watching. Stay tuned for more.